Profit loss analysis. Profit loss analysis is a really good way to determine if you got a gain or a loss in a business or if broke even. So whenever your revenue, which is your income, is less than the cost that you spent to make the material or whatever to get the product going, is less than, then we have a loss, right? If the revenue or what's coming in, the income, is equal to the money we spent, then we have a break even. If the revenue is greater than the amount of money we spent for costs, then that we have a profit. So our profit is recognized as capital P and is set equal to my revenue minus my costs. So if my income minus my costs gives me a negative value here, that means it's less than zero, then that means we got a loss. If my revenue minus my cost equals zero, right, then my profit is equal to zero. That means we have a break even. If my revenue minus my cost, my income minus the amount I spent is greater than zero, then I have a profit. So let's do these application problems down here. We're going to do a break-even analysis. We have this scenario where a university plans to raise money by selling custom printed shirts. The printer charge was $400 and it's $3.50 per shirt. They want to sell the shirts $15 each. The underlying question is, how many shirts must they make in order to sell to break even? So I'm going to let X represent the unknown. How many shirts, right? How many? So I'm going to put how many shirts. This is my side note. Must they make? All right. So now let's go back. We need to break this down now. We need to see what is our cost, because we are talking about P equals R minus C, which means profit equals revenue minus cost. So I'm going to have C of X is equal to, well, it says they have a $400 charge plus they have $3.50 per shirt. Then we have a revenue, right? We have a revenue of $15. They're going to sell it $15 per shirt. So now I'm going to set these two equal to each other and solve for X to get an idea about where I need to start with the number of shirts to sell. I'm going to list the R first because I want to have all my variables on one side and all my constants on the other side. So I'm going to say my revenue equals my cost. So my 15x set equal to 400 plus 3.5x. And I need to get the 3.5x to the other side. Since it's positive, I'm going to subtract it. What we do to one side, we do to the other. Solve this, I get 11.5x is equal to 400. The coefficient here on x is 11.5, so I need to divide by that to undo it and get x by itself. So now I got x is equal to 400 divided by 11.5. I get this number that's 34.78, and it keeps going up, right? We get this long decimal. So what I'm going to do is I'm going to put approximately instead of equal to, because it's not exact. So 34 is a whole number, right? So I'm going to look at it, not the 0.78, because I'm not going to get 0.78 of a shirt. And I'm going to turn around and plug it in my cost and get some answer. Kind of give me an idea. All right, so when I plug it in here, and I'm going to double check my math. I got a number. I want to double check, guys. It's always good to double check your work. 519. And then I'm going to take it and plug it in the revenue. And I get, yes, 510. All right, so if I take this up here and I say R minus see, right? I take that 510 minus that 519. Well, I got a -4. That's a loss. That's definitely not a break even. So 34 is not my number, but it's a small loss. Look. So why not go up to 35? Let's check. What if I made 35 shirts? Or I sold 35. Okay. So double check our math. Make sure what I got here on the paper is what I agree to. And yes, it is. I get 522.5. Let's plug it into my revenue. And we get 15 times that, 35. All right. So now I'm going to take that profit is equal to revenue minus cost. So I get 525 minus 522.5. I get $2.50 profit. So what does that tell me? That tells me between 34 to 35, I would get a break even, but we're not going to make a partial shirt. So yes, my answer would be 34 to 35. 35 is not exactly a break even, neither is 34. So we have to use them both in this particular scenario. Okay, so let's do our next example. So Consumer Price Index, CPI. So we got this Consumer Price Index is measured of the average change in prices over time from a designated reference period, which equals 100, right? It says that we're going to determine this index-based price consumer goods services from the year of 1960 to 2016. It says what net annual salary, annual means one, in 2016 would have the same purchasing power net annual salary of $13,000 in 1960. So we got a ratio going on here. The ratio is between 2016 year and 1960 year. We got this little table here given to us. Got an order pair of year versus index, right? So the year of 1960, we get an index of 29.6, and the year of 2016, we get an index of 241.7. So let's set up our ratio. Well, again, our ratio is 2016 to 1960. So when I set this up, I'm going to have that 241.7 divided by 29.6. And I'm going to set it up equal to. Well, what are we doing? We're talking about our index, our net annual salary. So in 2016, which was 241.7, we don't know what that annual net salary is, right? Because we're trying to determine what would give the same purchasing power. But we do know 13,000 was 1960. So now I need to solve for X. X is involved in a fraction. In order to solve for it, we got to undo the fraction. And what do I know is that it's on the numerator. So this is going to be easy. Since it's got this equal sign going on here, I can do cross multiplication, right? Just bring what's in the denominator here over to the other side of the equal sign in the numerator. I would do the same here, but there's no reason. X is already on top, so we're going to leave it alone. I'm just going to rewrite it where X is equal to 241.7 times that 13,000 divided by 29.6. So let's just double check. Always reduce if you can. Definitely multiply. Make sure you watch your zeros. You have the right amount of zeros. And I get, since it's a decimal, I'm going to put approximately 152,027. And we are not going to write it like this, right? We're going to rewrite it as 106,152. You could always double check your math, make sure that you got it typed in your calculator correctly. Or if you did it by pencil and paper, that's great. Make sure it's written down. So I know per year it's 106,152 per year. Watch the rounding and watch what it asks us for on your assignments on how to round. Okay, if you want to check your work, you would actually take this here. So this would be my answer. This would be for 2016. All right. What our underlining question was. All right, but to check, if you want to check your work, we would take this answer, divide it by that 13,000. Let's see what it gives you. And it's going to be approximately, you know, it's going to be a yucky looking number. And guys, I don't want you to think that I just threw this away. Is that tens place is a 0, so it didn't cause this number 2 to round up, so I did drop it off, okay? But I was rounding to the nearest whole number. Again, make sure and read the directions on what it asks for on the rounding. I'm going to round to the nearest tens here. I get 8.2 approximately, because it was 8.165538 and so on. So I'm going to round to the nearest tenth, so it gives 8.2. Now let's check what was given to us, that 241.7 divided by that 29.6. And let's see what the calculator gives us here and see if it equals the other. And yeah, I'm going to round to the nearest tenths and I get 8.2. So check, this was correct.